Welcome back. You are watching the live classes of the My Teacher program, and we are in physics portions for grade 12. We were discussing a concept from optics, which is nothing but the study of light. So you must have heard of this as well, like this year is celebrated. UNESCO declared this year 2015 as the International Year of Light. So in fact, today we had a wonderful program in the school as well based on that, which is nothing but the celebration of the 1000th year of the book on optics by Ibn al-Haytham. You must have heard of him. So if you haven't heard yet, you just Google it and find out the amazing facts about the wonderful personality and the well-known scientist Ibn al-Haytham, who wrote the book based on the experiments on light 1000 years back. So just imagine, after that lots of things came up to the world, and he explained many things related to light, and he was a great philosopher as well, as we always say about the scientists those days. But so since we were talking about optics, I just incidentally mentioned about this as well. So anyway, you must have observed these kind of celebrations, or we call it as observing the days of international importance. Alright, so we will come back to the board based questions of grade 12. Before break, we have just seen one question from one of the board papers of 2015, which was nothing but of the Ajmer region. Now I'm going to I'll show you another question, that is a second question of the same paper. You just read the question carefully. VI graph for a metallic wire at two different temperatures, T1 and T2, is shown in the figure. Which of the two temperatures higher and why? So the question, it appears to be a simple question, but at the same time there are chances of mistakes in this. One thing, see the diagram. First, when you get these kind of questions, first thing we are going to check is which quantity is there on the y axis and which is on the x axis. You can make out one thing, V comes on the y axis and I on the x axis. If that's the case, slope of the graph, that is delta V by delta I, this will straight away give you the resistance. Resistance is V by I, right? So slope straight away, you see the slope of this graph, these two graphs, that will straight away give you the resistance here in this case. But in case in the diagram, if this is I and this is V, then the reverse it is. Reciprocal of the slope only will give you the resistance. So that is one thing to think of. Okay, second thing, how will resistance of a conductor depend on temperature? Temperature dependence. You know, we have seen in current electricity lesson, when temperature increases for a metallic conductor, when temperature increases, electrons will be more happy, you know, they will be moving with more vigorously, right? They will be moving more vigorously means they will be colliding with more frequently. So if that's the case, the relaxation time, that is time interval between two successive collisions, will decrease, which will increase the resistivity, thereby resistance of the conductor increases. So what we understand is, as temperature increases, resistance also increases. Okay, so these two aspects you should understand. First thing, slope of the graph gives resistance because V is here on the y axis. Second thing, as temperature increases, resistance also increases. So here from the graph of T1 and T2, which of the two graphs represent a greater resistance? You know, greater slope. This is having greater slope. So T1, this first graph represents greater resistance. You know, as temperature increases, resistance also increases. Thereby, we can say T1 is at a higher temperature. So the answer to this question is T1 is higher than T2. This is the answer. If you got it, so see the question once again. Look at the question. The VI graph for a metallic wire, see on the question, of a metallic wire at two different temperatures, T1 and T2 is shown in the figure. Which of the two temperatures is higher and why? Okay, so the question, which of the two temperatures is higher and why? Answer is T1. You know, at temperature T1, the greater slope, so greater resistance. Now the third question, you have a look at the third question. look at the screen. A planar loop of rectangular shape is moved within a region of a uniform magnetic field along acting perpendicular to its plane. What is the direction of the and magnitude of the current induced in it? Direction and magnitude of the current. Rectangular shape is moved within a region of uniform magnetic field acting perpendicular to its plane. So, it is a very tricky question in fact. Okay, so the magnitude and direction of the induced current is what is asked. There is a uniform magnetic field like this, and it is given specifically it is moved, a rectangular loop, a planar rectangular loop is moved in the magnetic field within the magnetic field. That is quite important. Planar loop of rectangular shape is moved within a region of a uniform magnetic field acting perpendicular to its plane. What is the direction and magnitude of the current induced? See, within the magnetic field means what? No change in flux. You know, whenever there is a change in flux, only there is induced EMF developed according to Faraday. If there is induced EMF, only there is a current. Correct. So, in this question, since the loop is completely inside the magnetic field, there is no change in flux. So, for the change in flux to be possible, the loop should either enter or it should leave the magnetic field. One of these, either entering the magnetic field or leaving the magnetic field. Only such cases there is a change in flux, then only there is induced current. So, is it clear? So, here the answer is 0, no induced current. Alright, so be very clear. So, when it is coming out only there will be induced current. By the way, if it was coming out like this, coming in this way, then what would have been the direction of the induced current? See, the loop is, this is the loop and the loop is coming out like this. So, now the loop is here, let us say. So, it is going out. Going out means there is a decrease in the magnetic flux. If decrease in magnetic flux is there, you know, according to Lenz's law, there should be an opposition to the decrease. Opposition to the decrease means there will be current induced in such a way that it should produce a magnetic field in the opposite direction to the applied magnetic field. Okay. So, when you get time, you know, these programs always it's available in catch up. You can even take it again and see the questions, so that if at all you found that we were going a little fast, you would be able to make use of it again. Okay, just see how the things are getting solved. Once again, let me tell you, when the loop is going out, there is a change in flux. The change is decrease in flux. The decrease is to be opposed. For opposition of that, there should be a magnetic field in the, decrease to be opposed. So, there should be a magnetic field in the same direction. Decrease is to be opposed. That means it should be helped. For helping such a magnetic field, the induced current produced should be in the same direction as that of the applied magnetic field. Same direction, not opposite direction, same direction. So, the magnetic field is into the plane here now. So, this should produce a current in what direction? Clockwise current. If the current is clockwise, you know, the clockwise current produces magnetic field into the plane, anti-clockwise current will produce magnetic field out of the plane. So, if the loop was going out, the induced current would have been in the clockwise direction, so that it also will produce a magnetic field into the plane, which will oppose the decrease in flux as the loop is going out. Okay, so I just explained, I extended this question, that's it, but according to this question, the answer is 0. Right? You have to write 0, otherwise you will get 0. Okay, so go to the next question. Fourth question. Okay, look at the next question. When light travels from an optically denser medium to a rarer medium, why does the critical angle of incidence depends on the color of the light? Critical angle depends on color of the light. Why? So, we may explain it using the equation. So, simply the question is, why critical angle depends on color of light? First of all, you know the refractive index is 1 by sin IC. Okay, so the refractive index is 1 by sin IC. It means critical angle depends on refractive index. Okay, critical angle depends on refractive index. So, that way, and the question is what? Why does critical angle depend on color of light? Color of light. So look at the board here. Okay, you see here, look at the board. Sin IC critical angle depends on refractive index. Okay, but you know the refractive index, when we say about Snell's law, the ratio sin A by sin R is a constant for a given medium, given pair of media, and for a given color of light. So for a given color, the medium has a given refractive index. So once again, refractive index changes with color. Therefore, critical angle also changes with color. So why does critical angle depend on color of light? What's the answer to that? According to the color of light, refractive index changes. When refractive index changes, according to the equation, we see that the critical angle also changes. Therefore, critical angle depends on the color of light as well. Now look at the next question. This is question number 6. See the question on the screen. The question is, a variable resistor R is connected across a cell of EMF E and internal resistance small r as shown in the figure. Okay, read the question very carefully. Draw a plot showing the variation of 1. Terminal voltage with resistance, and 2. Current as a function of resistance. So these two graphs you'll have to plot. Okay, again it's a good question. So two graphs you'll have to plot when you connect a battery to a resistor. So very first thing is, we know V, so we have to plot the graph between V and R. So will it be true if I say V is equal to IR? Chance going wrong, again the mistake can happen like this. You write V is equal to IR. Okay, V is proportional to R, so we can draw a direct straight line graph. Will it be correct? V is proportional to R straight line. It's wrong, because when R changes, what else will change? I also will change. So if I is a constant only, we can say V is directly proportional to R. So what we should say is, I can replace I in terms of EMF. So what we will write? E by R plus R into R. That is, but again there is a problem, there are two R's. So we divide both numerator and denominator with R. So what do we get? E by 1 plus R by capital R. E by 1 plus R by capital R. Okay. So let us take it in this way. If R is equal to 0, what will be V? Capital R is 0. So when this is 0, otherwise you look at this, when R is 0, V is 0. Okay, V is 0. Then if R is equal to small r means internal resistance, then what will be V? This is 0. So V is equal to, I am putting small r as, sorry, capital R as small r. Okay, small letter r, if you write here, that is internal resistance, 1 plus 1. Okay, so 2, so E by 2. Fine. Then if R is equal to infinity, okay, R is equal to infinity, then what will be V? Okay, when R is equal to infinity, this part is infinity, then V is equal to E. Correct, because 1 by infinity is 0. So look at these points, 0, then you take a point R here, take the point E, this is EM of E. Okay, so and this is E by 2. So at this point, let us say when capital R is equal to small r, the EMF is E by 2. Alright, and this is, you see, just draw the straight line here, and when will this be equal to, when will V be equal to E? When R is infinity. You look at this, when R is infinity only V is, that is the case of open circuit. What is the definition of EMF? EMF is the terminal voltage when it is in an open circuit. When it is in an open circuit. Okay. Now, you can make out one thing. See, this will be the shape of the graph. Draw it like this, set R, E by 2. Then this will not touch here, because it will touch this line only if R is at infinity. So it goes like this. So see, this is the graph between V and R. Have you got it? Okay. Now what will be the graph between I and R? Let us consider that as well. I hope all of you understood this concept. Okay. Now graph between I and R. So what we will do is, we will take the equation again, I is equal to E by R plus R. Again similar situations we will take into account. R is 0. What will be R is, when R is 0? I is E by small r. When R is smaller, I is how much? E by 2r. Then when R is infinity, this is infinity, so when I becomes 0. R is infinity, I is equal to 0, this is infinity. So how will the graph? Initially when R is 0, maximum current, this is E by R. You may take this point as E by 2R. Okay. So first case, maximum current. Then this is when R is small r, capital R is equal to small r, then this will be the shape. After that what happens? When will current be 0? Only when R is infinity, that is open circuit again, current will be 0. So like this. So remember, it will not touch the x axis, again it will go like this. So that will be the shape of the graph. So make sure this is matching. It's clear? So two graphs, two good questions. These are graph between V and R, and the other one is graph between I and R. In fact, there are many questions related to this. Because of time constraint, I think this is the time for us to wind up today's program, today's class. You know, the working out different types of questions, especially from the book 1 of grade 12, it's really essential for doing good in the board examinations. So the board examination papers of 2015, if you refer from the websites, you will be definitely able to make out that the questions are not that direct. So if you do not have practice on such questions, you will find it difficult. So keeping that in view, keep preparing, but of course it's not like so much of complicated sums or something. So you should have a clear picture about the content if you want to answer such questions. So the lack of practicing of questions is what is exactly the reason for maybe the lower performances in the examinations. So keep that in view. It's not to see, not to make sure how you are working too much hard. Working hard but in the proper direction is something really important. Okay, so practice as many questions as possible, and of course we will have again class next week. We will have intimation from the TV as well. So, but be prepared. If you have any more questions to clear out, any more questions to clear the doubts on, you keep collecting them down, and you can get back to us definitely. So, and also if any chapters or any portions, if you have issues on, definitely we will do that. I will explain those things over here to help you out. So this classroom you make use of. This is the biggest classroom of the UAE. So make use of these classes, and just for today I am signing off. Otherwise we are going to wind up today's session, and next week again we will see. Till then, bye bye, take care.